This in turn increases flooding during the rainy season and reduces the snowmelt that flows into rivers. Beyond this, the glaciers that feed rivers during the dry season are melting. Some have disappeared entirely. Nowhere is the melting of glaciers of more concern than in Asia, where 1.3 billion people depend for their water supply on rivers originating in the Himalayan mountains and the adjacent Tibet-King-I Plateau. India's Gangotri Glacier, which supplies 70% of the water to the Ganges, is not only melting, it is doing so at an accelerated rate. If this melting continues to accelerate, the Gangotri's life expectancy will be measured in decades, and the Ganges will become a seasonal river, flowing only during the rainy season. For the 407 million Indians and Bangladeshis who live in the Ganges basin, this could be a life-threatening loss of water. In China, which is even more dependent than India on river water for irrigation, the situation is particularly challenging. Chinese government data show the glaciers on the Tibet-King-I Plateau, that feed both the Yellow and Yangtze rivers, are melting at 7% a year. The Yellow River, whose basin is home to 147 million people, could experience a large dry season flow reduction. The Yangtze River, by far the larger of the two, is threatened by the disappearance of glaciers as well. The basin's 369 million people rely heavily on rice from fields irrigated with Yangtze River water. Yao Tandong, a leading Chinese glaciologist, predicts that 2/3 of China's glaciers could be gone by 2060. The full-scale glacier shrinkage in the plateau region, Yao says, will eventually lead to an ecological catastrophe. Other Asian rivers that originate in this rooftop of the world include the Indus, with 178 million people in its basin in India and Pakistan, the Brahmaputra, which flows through Bangladesh, and the Mekong, which waters Cambodia, Laos, Thailand, and Vietnam. In Africa, Tanzania's snow-capped Kilimanjaro may soon be snow and ice-free. Ohio State University glaciologist Lonnie Thompson's studies of Kilimanjaro show that Africa's tallest mountain lost 33% of its ice field between 1989 and 2000. He projects that its snowcap could disappear entirely by 2015. Nearby Mount Kenya has lost 7 of its 18 glaciers. Local rivers fed by these glaciers are becoming seasonal rivers, generating conflict among the 2 million people who depend on them for water supplies during the dry season. Bernard Francoux, research director for the French government's Institute of Research and Development, believes that 80% of South American glaciers will disappear within the next 15 years. For countries like Bolivia, Ecuador, and Peru, which rely on glaciers for water for household and irrigation use, this is not good news. Peru, which stretches some 1,600 kilometers along the vast Andean mountain range, and which is home to 70% of the Earth's tropical glaciers, is in trouble. Some 22% of its glacial endowment, which feeds the many Peruvian rivers that supply water to the cities in the semi-arid coastal regions, has disappeared. Lonnie Thompson reports that the Quilcaya Glacier in southern Peru, which was retreating by 6 meters per year in the 1960s, is now retreating by 60 meters annually. Many of Peru's farmers irrigate their wheat and potatoes with the river water from these disappearing glaciers. During the dry season, farmers are totally dependent on irrigation water. For Peru's 28 million people, shrinking glaciers will eventually mean a shrinking food supply. Lima, a city of 7 million people, gets most of its water from 3 rivers high in the Andes, rivers that are fed partly by glacial melt. While the glaciers are melting, the river flows are above normal, but once they are gone, the river flows will drop sharply, leaving Lima with severe water shortages. In many agricultural regions, snow and ice masses are the leading source of irrigation and drinking water. In the southwestern United States, for instance, the Colorado River, the region's primary source of irrigation water, depends on snowfields in the Rockies for much of its flow. California, in addition to depending heavily on the Colorado, also relies on snowmelt from the Sierra Nevada in the eastern part of the state. Both the Sierra Nevada and the coastal range supply irrigation water to California's Central Valley, the world's fruit and vegetable basket. Preliminary results of an analysis of rising temperature effects on three major river systems in the western United States, the Columbia, the Sacramento, and the Colorado, indicate that the winter snowpack in the mountains feeding them will be dramatically reduced, and that winter rainfall and flooding will increase. With a business-as-usual energy policy, global climate models project a 70% reduction in the amount of snowpack for the western United States by mid-century. A detailed study of the Yakima River Valley, a vast fruit-growing region in Washington state, conducted by the U.S. Department of Energy's Pacific Northwest National Laboratory, shows progressively heavier harvest losses as the snowpack shrinks, reducing irrigation water flows. Agriculture in the Central Asian countries of Afghanistan, Kazakhstan, Kyrgyzstan, Tajikistan, Turkmenistan, and Uzbekistan depends heavily on snowmelt from the Hindu Kush, Pamir, and Tian mountain ranges for irrigation water. Nearby Iran gets much of its water from the snowmelt in the 5,700-meter-high Elburz Mountains between Tehran and the Caspian Sea. The snow and ice masses in the world's leading mountain ranges and the water they store are taken for granted simply because they have been there since before agriculture began. Now that is changing. If we continue raising the Earth's temperature, we risk losing the reservoirs in the sky on which cities and farmers depend. Melting ice and rising seas. Ice melting in mountainous regions not only affects river flows, it also affects sea level rise. On a larger scale, the melting of the Earth's two massive ice sheets, Antarctica and Greenland, could raise sea level enormously. If the Greenland ice sheet were to melt, it would raise sea level 7 meters. 23 feet. Melting of the West Antarctic ice sheet would raise sea level 5 meters, 16 feet. But even just partial melting of these ice sheets will have a dramatic effect on sea level rise. Senior scientists are noting that the IPCC projections of sea level rise during this century of 18 to 59 centimeters are already obsolete, and that a rise of 2 meters during this time is within range. Assessing the prospects for the Greenland ice sheet begins with looking at the warming of the Arctic region. A 2005 study, Impacts of a Warming Arctic, concluded that the Arctic is warming almost twice as fast as the rest of the planet. Conducted by the Arctic Climate Impact Assessment (ASIA) team, an international group of 300 scientists, the study found that in the regions surrounding the Arctic, including Alaska, Western Canada, and eastern Russia, winter temperatures have already climbed by 3-4 degrees Celsius, 4-7 degrees Fahrenheit, over the last half-century. Robert Carell, chair of ASIA, says this region is experiencing some of the most rapid and severe climate change on Earth. In testimony before the U.S. Senate Commerce Committee, Sheila Watt-Cloutier, an Inuit speaking on behalf of the 155,000 Inuits who live in Alaska, Canada, Greenland, and the Russian Federation, described their struggle to survive in the fast-changing Arctic climate as a snapshot of what is happening to the planet. She called the warming of the Arctic a defining event in the history of this planet. And she went on to say the Earth is literally melting. The ASIA report described how the retreat of the sea ice has devastating consequences for polar bears, whose very survival may be at stake. A subsequent report indicated that polar bears, struggling to survive, are turning to cannibalism. Also threatened are ice-dwelling seals, a basic food source for the Inuit. Since this 2005 report, there is new evidence that the problem is worse than previously thought. A team of scientists from the National Snow and Ice Data Center and the National Center for Atmospheric Research, which has compiled data on Arctic Ocean summer ice melting from 1953 to 2006, concluded that the ice is melting much faster than climate models had predicted. They found that from 1979 to 2006 the summer sea ice shrinkage accelerated to 9.1% a decade. In 2007, Arctic sea ice shrank some 20% below the previous record set in 2005. This suggests that the sea could be ice-free well before 2050, the earliest date projected by the IPCC in its 2007 report. Arctic scientist Julian Streve observed that the shrinking Arctic sea ice may have reached a tipping point that could trigger a cascade of climate change reaching into Earth's temperate quota regions. Reinforcing this concern is a recent study by Josefino Commisso, a senior scientist at NASA's Goddard Space Flight Center. Commisso reported for the first time that even the winter ice cover in the Arctic Ocean shrank by 6% in 2005, and again in 2006. This new development, combined with the news that the sea ice cover is thinning, provides further evidence that the ice is not recovering after its melt season, meaning that summer ice in the Arctic Ocean could disappear much sooner than earlier thought possible. Walt Meyer, a researcher at the U.S. National Snow and Ice Data Center who tracks the changes in Arctic sea ice, views the winter shrinkage with alarm. He believes there is a good chance that the Arctic tipping point has been reached. People have tried to think of ways we could get back to where we were. We keep going further and further in the hole, and it's getting harder and harder to get out of it. Some scientists now think that the Arctic Ocean could be ice-free in the summer as early as 2030. Scientists are concerned that positive feedback loops may be starting to kick in. This term refers to a situation where a trend already underway begins to reinforce itself. Two of these potential feedback mechanisms are of particular concern to scientists. The first, in the Arctic, is the albedo effect. When incoming sunlight strikes the ice in the Arctic Ocean, up to 70% of it is reflected back into space. Only 30% is absorbed as heat. As the Arctic sea ice melts, however, and the incoming sunlight hits the much darker open water, only 6% is reflected back into space, and 94% is converted into heat. This may account for the accelerating shrinkage of the Arctic sea ice and the rising regional temperature that directly affects the Greenland ice sheet. If all the ice in the Arctic Ocean melts, it will not affect sea level, because the ice is already in the water, but it will lead to a much warmer Arctic region as more of the incoming sunlight is absorbed as heat. This is of particular concern, because Greenland lies largely within the Arctic Circle. As the Arctic region warms, the island's ice sheet up to 1.6 kilometers, 1 mile, thick in places, is beginning to melt. The second positive feedback mechanism also has to do with ice melting. What scientists once thought was a fairly simple linear process, that is, a certain amount at the surface of an ice sheet melts each year, depending on the temperature, is now seen to be much more complicated. As the surface ice begins to melt, some of the water filters down through cracks in the glacier, lubricating the surface between the glacier and the rock beneath it. This accelerates the glacial flow and the carving of icebergs into the surrounding ocean. The relatively warm water flowing through the glacier also carries surface heat deep inside the ice sheet far faster than it would otherwise penetrate by simple conduction. Several recent studies report that the melting of the Greenland ice sheet is accelerating. A study published in Science in September 2006 reported that the rate of ice melt on the vast island has tripled over the last several years. That same month, the University of Colorado team published a study in Nature indicating that between April 2004 and April 2006 Greenland lost ice at a rate 2.5 times that of the preceding 2 years. In October 2006, a team of NASA scientists reported that the flow of glaciers into the sea was accelerating. Eric Rignott, a glaciologist at NASA's Jet Propulsion Laboratory, said, "None of this has been predicted by numerical models. and therefore all projections of the contribution of Greenland to sea level rise are way below reality. At the other end of the Earth, the 2-kilometer thick Antarctic ice sheet,